Hello and welcome to this video tutorial where I'm going to demonstrate the technique of reforecasting using ValQ. Now we know ValQ is an innovative self-service business planning and simulation solution that lets us instantly visualize and optimize scenarios in almost all the verticals of an organization, including but not limited to sales, supply chain operations, finance, human resource, and others. So we have quite a few blogs and videos that talk about ValQ and its utility aspects. Some of the informatives are so in depth and covers topics on how to structure and design the data in using this tool. Hence, in this video, I will straight away get on to the topic and showcase a way to reforecast and match an enterprise's budget on sales target. Sales target is the revenue from the goods sold. So you can see on my screen that we have a case study here, and we are going to see how ValQ will help us to reforecast with one of the methods practiced in the real world. The case study is as follows. This organization deals in a product segment which is ready to drink, and it's typically an FMCG kind of setup, and it's a manufacturing entity. This table, the second table, shows the financial period, their revenue calendar, which is Jan to December, their budget period. Budget announced is for the period Jan to December 2019. Budget has been released in the month of December 2018 on in the beginning of 52nd week of December 2000 of the year 2018, which is basically in the month December 2018. So more or less it was close to 24th of December when the budget was released. So this table shows the budget and revenue details. Revenue by the end of the year 2018 would be $100 million. With this, a year over year growth rate of 10% is observed. Desired growth rate for the organization for 2019 is 15%, and hence the budget has been announced for $115 million. Now, forecast, which is $110 million, is nothing but 10% of growth rate applied on the last revenue. To keep this demonstration very simple, and with this we have a gap of $5 million between budget and forecast. Now, supply chain team observed this gap, and as a planner, it is important to bridge this gap and make adjustments with the forecast by reforecasting at various class of intervals. Now, bear in mind, class of intervals are not time bound, but here we are talking about category of the data set, which I will showcase eventually in this video. So using ValQ, we have a value driver tree, and our data set will be fetched in the following sequence. So we have enterprise level data, we have regional level, we have quarterly data, and we have the data set which is at product group and at product level. Now, all the entire data set is a common file. It does not have separate sheets for separate aspects of this data. It is all merged together and appended commonly. So it will be very easy for us to understand the data set when we touch base that point. And what will happen post the data has been fetched inside the tool is there will be a relationship between a parent and a child node created right till the entire top-down flow relationship modeling is being set and achieved. So in the end, finally at product level, even at product level, I mean to say, we can have this relationship, and then we understand that reforecasting attempt is going to be applied between either product group or product level. So we're going to see how we do it on ValQ. But before we do it, we will also have to quickly understand how our data set looks like. So let's do that right away. Here is the Excel file which ValQ will fetch the data from. So you can see we have product segment in column A. We have product group here. We have products. We have regions in column D, that is north, east, west, and south. We have periods, all the 12 months of the year. We have all the 4 quarters here, Q1 all over till Q4. We have last year's product level sales, which is, as you can see, $100 million. We have current forecast of $110 million, which is basically an average at product level to keep it uniform and straight and simple for this demonstration. We have also applied the same average method in our current year budget, which is $115 million. The average is at product level. So just the same method we have applied for current year forecast, we have done it for budget as well to keep it very simple. Now, as we've known our data set, let us connect with ValQ and see how we simulate and reforecast and bring the gap of $5 million close to our budget and reduce the gap completely. So we are in the ecosystem of Microsoft Power BI where we have ValQ. As you know how to download ValQ through Microsoft Power BI and how to create these nodes, because as I said earlier, we have various blogs and videos about this on our website, ValQ, and under the tab get started, this is clearly visible, and you can see and you can get the idea on how to do this from those blogs and videos. So I won't speak much about it all over again in the interest of time, but I must notify all of you about a few of the nodes that are visible here and their purpose or relationship in this demonstration. So final index is a top node that shows the exact value appears this exact value that appears on the node ready to drink. So this value is being fetched from ready to drink. Now ready to drink is our current year forecast. We have created a relationship between final index and ready to drink, and ready to drink is our current year forecast as stated. The second node is a standalone node which does not have any simulation impact, which is our budget announced. It is coming from our current year budget. So you can see $115 million here. Gap is being achieved by subtracting our ready to drink from our budget announced. So 115 minus 110 gives you $5 million worth gap, which we have to reduce. Last year actuals is a standalone number, $100 million. Now bear in mind that any change that I do in the entire tree going forward will not impact anything on budget announced node, anything on last year actuals node. But yes, it will subsequently impact ready to drink node and gap, and it will also impact final index because final index is similar to ready to drink, and as we know gap is being achieved by subtracting ready to drink, that is our current year forecast, from our budget announced. So let's start the simulation, and the node that starts building the value driver tree and parent child relationship is ready to drink, as we know, and we must follow this relationship to observe the connections from a top down perspective. So let's do that now. We have regions. Further, when we expand it, we will have quarters. Going ahead, we observed our product groups, and finally we also have our products. So this value driver tree or a parent child relationship is already being done. Now I had spoken about the category level inputs, the class intervals. So this is what I was talking about. Our data, as we saw on the Excel, had these columns. These are the values that has been fetched directly from the data. As you can see here, the entire Excel sheet has been columnized and been available in the fields over here. So this now makes sense on from where our data has been coming from and how it is talking, creating a relationship between a parent and a child. So we have product segment, we have region, we have quarters, we have product groups and product. This is exactly what we observed here. So from a top-down method perspective, our value driver tree connections and relationships have been built, and now we simulate and start the reforecasting process. So when I collapse this, I can get into the first level of relationship in the VDT, value driver tree. I get into north, and let's say I get into the first quarter and I increase a little bit of canned juices. I also increase a little bit of energy drinks, and I increase flavored milk as well. In Q2, I see a reduction in canned juices. For energy drinks, I am fine, but for flavored milks, I continue to increase the simulation. For Q3 and Q4, I just want to increase energy drinks a little bit. And for Q4 I increase energy drinks as well as I increase the flavored milk. So what starts happening here is, as we know that at the node level, whatever changes we do using the conditional formatting, it all starts simulating the value, and we see that from $110 million, because of the value driver tree connection between parent and children, our ready to drink node, which is our forecast, has increased from $110 million to $111 million. So let's do it for East. If I am confident that on East, I will do some improvement in energy drinks in the period of quarter 2, and in flavored milks, if I observe some increase or I anticipate some high sales, I will do that. For others, if I do not have an anticipation, I will keep them as it is. For West, let me get into Q1, and I will do some simulations at product level. I'm very confident that my chocolate is going to be sold for more than $100 million, and so as vanilla. It's on the fly and very easy, and I can now see that for West and for East, whatever simulations I have attempted, that has increased my overall forecast by $2.25 million. You see the gap is also reducing, and that's why it's turning green. Now earlier the gap was somewhere here, but after simulations, the new derivative is basically showing us a gap which is reduced. Similarly, in ready to drink, we had a standard baseline forecast which you can see on the dotted lines, and after the simulation at quarter, region, and product group level, and in fact at product level as well, you see a new chart has been created. A new graph has been created on the node, I mean to say. So you see the impact of changes on the nodes as well, and we didn't do anything on the south, so let's do in south as well, just to have a quick one. South in Q3, I believe I can do a lot in canned juices as a planner, so I'm going to increase apple, uh, and I'm going to increase mixed fruit. All right, so in Q3 for south I'm done. Now I see it's increased further, $112.68 million. When I get out of the design mode, I can see that I have a simulation period of Jan to December. My gap has been reduced significantly, and I can continue to do it at product level or at least at product group level to ensure that the gap is further reduced and I bring my entire forecast at the budget level. So won't talk much about the off design panel over here, where we have our KPIs. We can build our constraints. We can also have our key inputs. Now key inputs is coming from the node final index. As you can see here, budget announced shows this value, and last year actual shows this value. So we can clearly see that now the gap is very limited or very minimal between the final index and the budget. One more interesting thing is that by clicking on the node, we can see the details of the changes before and after simulation. So let me click on the node ready to drink, and you can see the changes that have been applied. The trend is now changed. We kept Q1 as it is probably, and we reduced something in Q2. In Q3 there is an increase, and even in Q4 there is an increase. So every aspect has been increased in terms of the enterprise's overall forecast. So here we have the simulated baseline compared to the comparison. Now comparison was $9.58 million on an average of month. $115 million is a yearly number, as we know. Now, based on this, we are now short of only 2% of our total annual revenue. So we are at 112.68, which is showing a variance of 2% now. Earlier, the variance was way higher than this. So we have simulated 4% better impact on the monthly level and 2% better impact on the yearly level. So original baseline is this. This is what we had originally. Now we have reached 9.58, and original forecast from $110 million has reached to $112 million. And we even know that this product has a table view, and every change with necessary or applicable variance can be seen over here. So let's go to the table view. So a table view shows us at all the relationship nodes, all these levels, what is the trend, what is the change that we have done, what was the simulated baseline now, what is the impact of simulation, what is the variance, and these key performance indicators as a part of each simulation can be observed here. This is our original baseline. What was our original variance? So original variance, for example, in overall was $5 million. Now it is simulation impact has reduced it by 2%. So variance is still at -2%, which can be further simulated and corrected as per the intellect of the planning cell of the operations team. In the end, this simulation can also be published through Power BI services, and the same can be shared, viewed, modified, or downloaded by someone with whom we share the rights to do so. So we have a publish option here. I won't get into this right now. Eventually, we can also get this file downloaded in the form of an Excel and can be shared with other colleagues from various departments interconnected with operations, just to have them the visibility of the forecast and the reforecasting, the simulations which has happened. So the change can be easily communicated in the form of a report by downloading it through Excel. And with this, I believe we come to the end of this video, and I hope you liked this tutorial and found it to be helpful. Keep watching this space for more such planning simulations, and ValQ has and will make planning extremely easy and interesting and intuitive. Thank you very much.